Hello everyone. I will be teaching on a topic data communication and computer networking. And what is data communication? In simple terms, data communication means is a movement of encoded information from one point to another by means of electronic transmission system. Another definition can as well be the exchange of data between two devices via some form of transmission medium, which can be wired or wireless. You can as well say it's transferring of digital information, usually in binary form, between two or more points or terminals. And let's go straight to the components of data communication. They are usually 5, but let's get started with one. The first one is sources, and the source, it is the transmitter of data. For example, terminals, computers, or mainframe. The second component is medium, or the transmission medium, and this is the communication stream through which data is being transmitted. An example can be cables, microwaves, fiber optics, radio frequencies, infrared wires, and etc. The third one is a receiver. A receiver is also a component of data communication, and the receiver is the receiver of the data transmitted. For example, a printer, a terminal, a mainframe, and a computer. The diagram you can see is shows the components of data communication system, and this is the model. And the first one, these are the first component, as you can see, is the source. As we said, a source is also what we call the sender, and the sender is responsible for initiating and generating the data to be transmitted. The second one is the transmitter. The transmitter from the sender is a transmitter, and the transmitter is a device that encodes and transfers the data into signals suitable for transmitting over the chosen transmission medium. So from the transmitter is the transmission medium, and the transmission medium we can say is a physical channel or a visual channel through which the encoded signal are transmitted. These can include cables, fiber optics. Okay. The other component is the receiver. The receiver, these are the devices that receive the transmitted signals and decodes them back into usable data. So from the transmission medium is a receiver, and the last one is the destination. The destination, these are the intended recipients or the endpoint of the transmitted data. Here the data is transmitted and it is received. Okay. So in data communication, we have the four fundamental criteria or characteristics, and they include, the first one is delivery. Here the system must deliver data to the correct destination. The delivery means that the system must deliver data to the correct destination. The second one is accuracy. The system must deliver the data accurately. The data to be delivered must be accurate. And the third criteria is timeliness. The system must deliver data in a timely manner. This means that the data to be delivered must be on time and never late. And the fourth criteria for effective data communication is jitter. Jitter refers to the variation in the packet arrival time. This means that for many data communications to be transmitted, the first data to be sent must be the first to be received and never late. We'll move on to data communication and terminal equipment. Data communication and terminal equipment. And the first equipment is the DCE, data communication equipment. These are the hardware devices that can be used to establish, maintain, and terminate communication between a data source and its destination, mostly used to perform signal exchange, coding, and line clocking tasks as part of intermediate equipment or DTE. An example can be a modem. So, what is a modem? A modem, you can say a modem is a device that allows computers and other devices to connect to the internet. The second terminal equipment includes the data terminal equipment DTE, and this is the interface equipment which is source or destination in communication. The terminal equipment is capable of converting information to signal and also reconverting received signals. As you can see, this is the data communication and terminal equipment. As you can see, there's a DTE, data terminal equipment, then sent through the modem. These are the cables, goes back to another modem, then to another DTE equipment. Okay. The DCE, we said that the DCE are devices that establish, they can also control, they can also terminate communication channel, these ones, and the modem are included in the DCE. And then for the DTE, they are devices that generate, they can process, and they can as well terminate data for communication purposes. So for the DTE, they generate, they process, and they can as well terminate. And for the DCE equipment, they can control, they terminate, and even establish a communication channel. Let's move on to communication, to computer network or computer networking. What is computer network? Computer network is an interconnectivity of two or more computer systems for the purpose of sharing data. It consists of two or more autonomous computers connected to each other so that they can share resources. Networking arose from the need to share resources in a timely fashion. That is what you call computer networking. Let's move on to types of networks, types of computer networks. And the first one is personal area network. So what is personal area network? A personal area network, or PAN in simple terms, is the interconnection of information technology devices within the range of an individual person, typically within a range of 10 meters. Another type of network is local area network. A local area network, also called LAN, is usually privately owned and links the devices in a single office, building, or a campus. The third type of network is metropolitan area network. The metropolitan area network, also called MAN, is a network with a size between a LAN and a WAN. A WAN is a wide area network. It normally covers the areas inside a town or a city. It is in between LAN, local area network, and WAN, wide area network. The fourth type of a network is wide area network. Wide area network, also called WAN, is larger than the MAN and larger than the local area network. A wide area network video information covers information from a large geographical area that may comprise a country, a continent, or even the whole world. A WAN can be complex as the backbone that connects the internet or as simple as a dial-up line can connect a home computer to the internet. Let's move on to network topologies. As you can see, we have 6 types of network topologies. There are more, but in this topic, we are going to cover 6 types, and you'll be required to go and find out more. I will go through the 6, but you will have to go and discover more about them. So what is a bus topology? A bus topology consists of a single cable that runs to every working station. It's a single cable that runs to every working station. What is a ring topology? A ring topology connects computers on a single circle of a cable, like a ring. And the third one is a star topology. In star topology, computers are connected by cable segments to a centralized component called a hub or a switch. So in star, there must be a hub or a switch. Signals are transmitted from the sender computer through the hub or the switch to all computers in the network. The fourth one is a tree topology, and in tree topology, it is a network configuration where multiple devices are interconnected in a hierarchical structure. In tree, they must be in hierarchy. The layout is in hierarchy, and in the next page, we'll see that we have the 7 network topologies, and the first one, as you can see, is the ring. And as you can see, the computers, the nodes represent the computers, and as you can see, they're connected on a single line, on a single circle of a cable. As you can see, there is no terminated ends. You see, they are both connected. And this one is line topology, and in line topology, network configuration, the network configuration in line is where devices are connected in a linear fashion. As you can see, they are in one line. And for the tree, as you can see, they are in hierarchy form. This is a hierarchy design. For the bus, it consists of a single cable that runs in every working station. As you can see, it is a single line. As you can see, it consists of a single cable that runs to every working station. For the star, looks like a star. Computers are connected by cable segments to centralized components called a hub. So this one at the middle is one computer, but it's the hub. It's the one that connects, that all the computers are connected to it. This is star topology. Computers are connected by cable segments to centralized components called a hub or a switch. I want you to go and read more on the advantages and the disadvantages of the network topologies.